So there are few more things like
Let's
for sorry, Ravi, go on.
sir, please share that last theory videos also.
Okay, sure. I will share it today itself. So last week we have covered most of the thing, but still few labs are pending and few more things that need to be checked and looked into. So let's start with one of the lab that was the firewall lab. So we did discuss about Azure firewall last week. The only one part that was left was the firewall lab. So about the firewall, it works on the model of hub and spoke. Okay, so suppose this is your Azure firewall. You have to place Azure firewall in different subnet, that is firewall subnet. No other VM should be in this subnet. There could be other subnet in your virtual network or more than one. Sub 1, sub 2. You can connect your on-prem and the other end is the internet. So this is the hub and these are the spoke. How it works? Suppose in our architecture we have different zones, like if you heard of the DMZ zones. So they are internet structure where servers are placed. This is the internal part where servers are placed. Externally, in order to access this server, there could be any jump server or bastion server. So the purpose of bastion or jump server is any user sitting outside can easily reach this bastion server, but the user cannot reach these servers directly. So in order to make sure there is some firewall sitting in between this bastion server and the internal server, so that any user coming from inside to outside or the internal servers, if they are trying to go to outside to any place, this firewall should be in picture and we should restrict and protect our internal resources. That's the main purpose of firewall. So how we are gonna do this? We'll create a firewall subnet. We will install a firewall inside the subnet. There will be two additional subnets, subnet 1, subnet 2. Inside one subnet, there will be a virtual machine VM that will act as bastion server. If you have any doubt about bastion terminology or jump server technology, so it is nothing. It is the way how you can connect to your internal resources indirectly. That means if you are the user and you need to access your organization servers. Nowadays, no organization, no good organization let you directly connect your server. No. So they will create another server in between. This server will provide access, limited access to users. It will collect logs, who's gonna log in, who's going where, and it will implement some security measures. So user will first connect to this server, and from this server he can connect to any internal organization resources. So we are going to create this bastion server in front of our whole premises network. We'll create another server, that is Linux server, and for bastion there will be public IP. For Linux server there won't be any public IP. That means in order to connect to Linux server, we cannot come from internet directly to Linux server. We have to first come to the Bastion server, and since this is inside a VNet, if there are 10 subnet, they are all routable by default. So we will be able to route to this Linux machine. So we'll do SSH from Bastion server to connect with the Linux machine. And once we are connected with the Linux machine, we'll see firewall. So what we'll see? There are network rule in the firewall. There are application rule in the firewall. Network rule means IP address, port, mapping or blocking. Application means like HTTPS, FTP or SCP or SSH. So rules for the application level things, rules for the network level thing like IP, source port, destination port, and there is additional feature while all have for this net rules. So these are the two rules. The third one is net rule. What is net? Suppose this is your organization. This is one public IP on any router somewhere. If outside user or inside user, any one of them are trying to reach each other. So if this is trying to each other, it will come first to public IP. Then there will be network address translation from public IP to private IP. Okay, over here, if there is router firewall, it will convert this public IP to private IP and will send it to the user. Guys, I just want to check if my sound is okay and if there is some issue. Is there any issue?
No, sir.
Okay, fine.
No, sir.
Okay, so user trying to reach internal, if there is someone external trying to reach internal, he'll come to first router firewall or whatever device is at the perimeter. So he'll come here and there will be network address translation from public to private and then it will be sent to internal user. Or if some internal user is trying to reach some like YouTube externally, he'll come to first router from his private IP. Then there will be network address translation. It will be converted to public IP. It will go over internet. So only public IP will be routable over internet and inside the any organization private IP is routable. So the third rule it performs is the network address translation. So if suppose we have public leg on one of our server, so it will first come to the firewall and then firewall will perform network address translation, then the send the incoming packet to the server. Okay guys, any doubt in this? Okay, so let's look at the lab. Okay, so initially if I'll go to virtual machines or suppose we are going to virtual network. So first what we are going to do, we are going to create a virtual network test vnet. So once test vnet is created, we'll create few subnets in the virtual machine like Azure firewall subnet. So the purpose of this firewall subnet is firewall only, nothing else. We can create additional subnets like I created subnet 1, then subnet 2, and will place virtual machine in these subnet. So here there will be firewall, here there will be two virtual machines. So we came to virtual network. We added one. Just a sec. Okay, I created new resource group named lab. lab vnet. Next, okay, here I will create different subnets like best in subnet, and since this is the 10.00 range, 10.0.1.0/24, add and the subnet backend subnet dot 0.2.0/24, add, and the third one will be firewall subnet. This is the firewall subnet 10.0.3.0/24, add. So now we have three subnets. Review and create. Create. So we are going to create three subnet. Now what we'll do, we'll install a firewall in firewall subnet to VM1 and VM2 in two different subnet. So I will go over here. I will go to firewall, or let's create virtual machine first. Add virtual machine. Resource group lab. Virtual machine name. Firewall machine 1. This will be Bastion machine that will be sitting in the at the front. Review and create. So our DP is 3389 is open for this machine since it will be sitting at the top of our or at the front of our virtual network. So that public IP is accessible through this. Next, we'll create another virtual machine that will be sitting at the back end. And here we'll create a Linux virtual machine. So I'll go to lab, lab, backend. Same, it will be Linux. We'll use password. Next, next. So we'll remove public IP from here. So we do not want any public IP at the backend, and network interface card is okay. Leave it. Okay, so we do not want any public IP address at the backend. Review and create. Create. So until now, what we did, we create a VNet. Inside this VNet, we created three subnet. We, one, So where we created a VM with public IP. Over here we created another VM without public IP. Okay. Next we'll create a firewall over here, and then we'll create a root table. So until now we have created sub 1, sub 2, next firewall, and then we'll create a root table. I think deployment is done. Next firewall. Add lab lab firewall name. I will use existing virtual network, and that will be the lab VNet. Public IP I will create new lab 2 VNet. So for the firewall I'm adding a public IP, and I gave the VNet on which we are creating the firewall. Next, next, I do not want to tag it, and then create. So it is going to this, sorry, this address space. So I won't create this firewall. I will just go hop onto the firewall I have already created. There is running firewall. So if you also see, this firewall is created. Next, I will create a root table. So I will go to root table, RT, create a root table, add. So when if I came to root table, I will select a resource group, region, same region, lab RT, review and create. So until now, we created VNet, subnet, VMs, firewalls, root table. Now I will add roots to this root table. So this is our root table. So root table is just like empty box. So this is the root table. First, you have to associate any subnet with this root table. So suppose our backend subnet was sub2. So what I have to do? First, we have to add this subnet sub2 inside this root table. Okay. Next, since this is root table is associated with this subnet, next we'll decide where to send all the packets that belong to sub2. So suppose there is another sub1, or if there is some firewall, or suppose if there is another firewall or another virtual appliances like Palo Alto or Fortinet or something else. So this root table is associated with this subnet. Now we'll decide where to send the packets. So just so we'll decide, like, we'll create routes that all the packets coming from sub1, please send it to sub2, send it to sub1, or in our case we are creating a firewall. So all the packets that are coming from sub2, please send them to firewall, or all the packets that are coming from sub 2, please send it to Palo Alto. So this is how we can create the route. So we'll first decide what we need to send, just like a static IP, static route. So if you are aware of the static route, you define the destination, suppose 192.168.0.1. You add subnet, so 250 or 250 or 250, and you decide next hop. So you first decide destination and where is the next hop to send this packet. Similarly, over here we'll create a route, static route, where we'll decide that all the packets that is from sub 2, send it next hop should be the sub 1, or next hop should be the firewall, or next hop should be the PA firewall or Fortinet or checkpoint, any other firewall. So like over here, I will go to subnet, and on which subnet we want to work, it depends on the subnet we want to work. Like if we want to associate it with the backend subnet that will be used for the firewall, I will associate that backend subnet. So at lab vnet, and which subnet? So this is the backend subnet. So I will associate the backend subnet. Okay. So this is associated. Now we'll create route for this subnet. All the packet coming from this subnet should be routed to where? So I will go to routes. I will add. So it says, okay, route name sub to route, address prefix, where you want the destination. So we'll see over here. It clearly says the destination IP address range in the CIDR notation. This applies to if the destination IP address of the packet falls in the range. So if it matches the route, what should be the next section? So if we are going to create it as default route, we'll add 0.0.0/0. So this is the default route. Any packet for this destined from anywhere should be sent to. So we have options, different options like virtual network gateway, or I will just drop this tab. There should be virtual appliance or subnet. So it depends where we want to send this packet, since we are creating a route. So you can see that I want route all the traffic that should going to 0.0, send it to virtual network or virtual network gateway or different VNet or internet or virtual appliances. So there are four options, different options. Over here we are creating a virtual appliance named firewall, Azure Firewall. So we'll select Azure Firewall. And what should be the next hop? Since we are sending it to the virtual appliance, next hop should be the private IP of the firewall. So if I will go to firewall, and if I will see the IP, so 10.4.4.4. So this is the private IP of the firewall. So we'll add 10.4.4.4 as the next hop. So it means all the packets that will come from subnet 2 will go to the firewall, and then firewall will decide if it needs to send it over internet or any other subnet, sorry, another VNet or on premises. So firewall act as hub. Now everything will be sent to firewall at the hub location, and it will be sent to next spoke location or destination. So I added the route. Now I will go to firewall and I will create two rules. So first rule, network rule for verifying source IP, destination IP, port, and protocol, just like NSG. Second rule, application rule for the purpose of verifying HTTP, FTP protocol, or HTTPS, or SCP, or SSH. So we can create allow or deny rule, and it works in the same way just like NSG. So the rule that is sitting on the top is having the highest priority if any of the rule matches. So it will stop looking at the bottom and it will execute it. So if there is deny at the top, it won't go to the next rule that says allow. So we need to make sure that rules are created in a correct order or in correct way. So if I will go over here, I will go to rules. So there are, like I told you, there are three rules. First, network address translation rule. The purpose of this rule is if there is some server that need public IP. This is suppose Outlook server or Facebook server or YouTube server, and users are accessing this server through www.youtube.com. So it should resolve into some public IP. And it is resolved to the public IP, it will reach to this firewall from internet, and over here there will be netting performed from public IP to private IP, and then it will send it to the designated server. So if we are assigning any public IP to any particular machine and we want it go through the firewall, so we'll create a net rule. Next is network rule. Network rule is for the port, source, destination, etc. So if I will go to add network rule, so you will see that I need to give a name, I need to give it a priority, then action, allow, deny, and then rules. So IP address, protocol, source type, source as a destination address, and destination port. So like this. Back coming to firewall, there is application rule. So purpose of the application rule is for the application filtering purpose. Okay. Name, we need to select a priority. Action, allow or deny. Next, target FQDN, like www name is just a name. Then source IP, source IP, then source. If we do not have any predefined source, we can start select star for everything. Then protocol, HTTP, SCP, or FTP, or HTTPS, and target FQDN. Target FQDN means fully qualified domain name, like www.youtube.com, like that. So we can select this application rule so that the any user, if trying to access youtube.com, just a second, give me a minute, guys. Sorry guys, I got call from the office. Okay, so where are we? So we are in the application rule. So suppose there's some website www.facebook.com and we want only secure access to this Facebook like HTTPS, or suppose there is some website www.googledrive.com, something like that. So we want only secure file transfer, that is SCP, that work on the port 22 like SSH. So we can create a application rule. So if we'll try SCP for the Google Drive, it will work. If we'll try anything else, it won't work. Or suppose we want HTTP access only to www.youtube.com, not to Facebook or someone else, some any website. So we'll create an application rule like HTTPS only to fb.com or youtube.com. So we'll be able to we'll be able to browse only Facebook or YouTube, nothing else. So we can create the different application rule depends upon what type of application we want to access. So we'll see the existing rule I created. So there are two rules. For the network rule, it says priority 100 allow DNS. Okay, let me click this. So the existing network rule I have already created. This says 100. Okay, here it is. Protocol any, source IP address any, destination IP 8.8.8. This is the Google DNS. Destination port DNS port number is 53. Just a second. विपिन, हेलो विपिन। अच्छा चलो पहले मैं इसे कंप्लीट करता हूँ, मैं बात करता हूँ हमसे। ओके सो वी आर ओवर हियर. So I already created one rule that says source all, destination Google DNS and destination port 53. So for the DNS purpose, only allow 8.8.8.8. Firewall by default will deny everything else. So by default, it will deny everything else. So if we want the DNS to work, this should be the way it should work. Only through 8.8.8. So if we'll try another DNS like 8.8.4.4, it won't work because our firewall is denying it. Similarly, if I will go to the application rule, this is the running rule I already created. This rule says that priority is 150, action is allow, and for what? HTTP and HTTPS. Source should all star mean all for all incoming IP address. Protocol this allow www.google.com. So it by default it will deny any other application, and for google.com it will allow HTTP and HTTPS. Okay, so I created two rules in the firewall, one for the application, one for the network. So we can add additional rules as well. So until now, what we did, just briefing you guys, we create VNet, we create 3D subnet, sub1, sub2, uh, firewall subnet. On sub1, we created Windows VM or Bastion server. On this, there is public IP associated. We create another subnet, Linux VM backend. We created a firewall. Next, we created a root table. Inside root table, we added a subnet that is for the backend one. This backend has no public IP. So we added sub2 to this, and we added a root that says any packet, since the subnet associated is the sub2, any packet that is destination for anywhere should be routed to firewall, that is virtual appliances. Since this is a sub2, so any packet that should go to sub anywhere from sub2 should first reach firewall, and then it will go to either sub1 or it will go to internet. So that is the way. So I went to firewall and I added two rules. First one, network rule. For over here we created it for the DNS resolution should be done only for 8.8.8 Google DNS. For other DNS it won't work. Then we created a application rule. An application rule says allow HTTP or HTTPS only for Google. Except for Google, by default deny. So we did all these things, and if I'll go to the lab again. So first I will log in into the Bastion or front-end server. So if I'll see this is the Bastion server. I will copy this RDP and log in into this server. Okay, so I'm inside this server. Okay, next. Okay, so here's the I will open the PowerShell, and from here this is the Windows server front-end server. Next I will SSH into the subnet 2, that is Linux server. So I will log into this Linux server that is sitting inside, and there's firewall facing this server from this sub2. We'll try all both two rules like DNS rule that should go through 8.8.8.8. Second rule, application rule that is for HTTP and HTTPS. Okay, guys. So I'll perform SSH at the rate, and we'll see the public private IP of the internal server, that is backend Linux server. Its private IP is 10.4.2.4. It is asking for password. So we are inside Linux server through SSH. We connected Linux server through SSH. Next, we'll test the network rule that is allowed DNS only for 8.8.8. So when we are working for the Linux command line has different command. For DNS, it uses the command dig. So dig will resolve www.microsoft.com at 8.8.8. So we'll see dig www.microsoft.com 8.8.8. Enter. So it resolved 8.8.8. Resolved Microsoft IP. You can see that. Next, I will use another server 8.8.4.4. Okay, I will enter. So it will wait for some time and then it will reject. It won't resolve. So over here, Microsoft IP was 23.20.160.167. Now we won't be able to find Microsoft IP because it is resolving as per firewall rule only for this DNS server. So after a couple of seconds, it will fail. Okay, it failed. No server can be reached. Next, we will check for another instead of Microsoft, some other like youtube.com. So it resolved the youtube.com. But if I'll change this server to another server like 4.4.4, that is Google server as well, it won't resolve. And eventually it will fail like earlier. No server can be reached. So it will fail. Next, this was the network rule that we created for the DNS. Next should be the HTTPS. So this is the command line. We'll use curl. The purpose of curl is to browse website on the Linux command line. So I will use curl https www.facebook.com. But the thing is that when we created application rule, it says HTTP or HTTPS allow only for google.com. So no other application should be accessible except for google.com and only on application HTTPS and HTTP. So if we'll try facebook.com, it should fail. So it failed. It says open SSL connect SSL error. If I will try google.com, it is on. So on the command line, it is showing everything that is of the website that is written in the scripted form. If I will try Google, Facebook, or YouTube, next time it won't resolve. So it failed. So you can see that application rule worked only for Google, not for the YouTube and Facebook. So this is how we can restrict certain limitation on what we can access on the application level or network level. We will want the network address translation. We can go to the firewall, and if we want any server to have public IP resolution, we can go to rule. We can add a net rule and name priority, name source IP, what should be the IP, destination address, what should be the destination address, destination port and all. Suppose source IP is the public IP, then it will be 16.1.1.2 something like that, and destination if we are going to net it into the private one 192.168.1.1, and what should be destination and translated address port we can select in destination port 8080 or 443 or something like that, and translated address what should be the translated address and what should be the translated port. This is how we can perform the netting if we have any requirement of the netting. There are a few more things like public IP configuration. So since we are accessing the internet from that subnet too, so it will go through this public IP. So there is one IP. So what we are trying Google and netting DNS, this should reach first. This public IP then should go outside. There are a few features like firewall provide like threat intelligence. So if we it find any threat and or something like that, we can select alert only or deny alert and deny. So we'll select alert and deny. If any threat is detected by the firewall, it will default by default deny it and drop the packet. And if we'll send select alert, it will send the alert that there is some issue with this communication. So you need to stop it or whatever you want. So this is the firewall manager where you can create a firewall policy, virtual hubs and virtual network. Next, this DNS, if you added your own DNS, you can enable this feature on the firewall for DNS resolution. So you can select either default Azure or custom added created by you if you are going to create some DNS server. And there are a few more monitoring parts. So when we're looking into the monitoring, we can look over here or in a quick review, we can select like on the Azure firewall, we can select, okay, I want to check firewall health state and aggregation average. So it will see it's 100% good. So there is no issue. Or instead of 24 hours, suppose we are adding it for 30 minutes. Okay, so its health is good, 100%, no issue. Similarly, if you want to check anything else, we can select on the monitoring part like diagnostic settings for sending the logs to somewhere else, or we can check logs from logs ported. So we have to look into the log analytics, but we'll look at later. This is all we have on the firewall. Any doubts, any questions?
No, sir.
No, sir.
So lab was all good or any
Yes.
doubt in the lab?
Labs are good.
So guys, I need five. Yeah, go on. Anyone, anything?
No, sir.
Okay, so I need 5 minute break. I got a call from the office. I need to check that. Then we will resume this class. Okay,
Okay, sir.
just a 5 minute break. So guys, any question in this Azure firewall part?
No,
No, sir.
sir.
Sir, can you once show the topology from the network watcher?
Sure.
Thank you. Sir, resource group was lab, right, on which we were working.
Yeah, I mean, I created the lab one, but this was the one I
Oh,
showed
it
it.
was the previous. Okay, okay, okay. Got
So this is the best end server, front end server. Through this IP, we got connected into the Windows VM. This is the backend server, Linux server. Okay. This is the firewall subnet and this is the firewall. And this was the root, test root I created for this. This is leave it like, I mean, there are few more extra steps or extra things for other purpose. So this is the topology. So if you want from this backend to public, you will go to, you will look into the test root table and then you will go to the Azure firewall subnet inside the firewall and then you will go outside to the public. So if I will draw this map, it will look like this. This is the firewall and firewall subnet. This is the backend and as per root table or root, every traffic from the backend should first go to firewall. And there is firewall public leg or firewall public IP address. So any traffic that from backend subnet should suppose there is another subnet sub one or front end. Okay. So front end to backend you can directly connect because there is nothing in between. But if from backend to anywhere, it should first come to firewall. And if public, it will go outside from the public leg. Is it okay?
yes, sir.
Yes, sir.
And if you will look at the network watcher, so this is how it looks. And the reason why it is showing firewall over here, because when we created the root 2, we associated subnet 2 with root 2. Am I good?
Yes, sir.
Yes, sir.
Okay, so this was the firewall lab and firewall part. Next, one more thing. We'll see half of it today and the rest half tomorrow. That will be the point to site VPN. Point is your laptop and site is our Azure subnet or VNet. So when it comes to connectivity, there are three options. First, point to site, that is for users like Any Connect, Pulse Secure, or Global Protect. Over here, it will be the Azure AZ-VPN. Second one is site-to-site VPN. When you have on-premises network, and there is Azure. So you create a site-to-site VPN for the connectivity. And the third one is express route. We discussed in the last class. From site to site over a MP, you can say it MPLS network or private network or VPN. So these are the few options. These two, site and to site and site to express route, we cannot do this because we do not have on premises or any provider, but we can see point to site over here. So for point to site VPN, like over here, we have to first create a gateway subnet. First, we'll create a gateway subnet. From gateway subnet, we'll create a VPN gateway or VNet gateway. Gateway from external bodies can reach to this VNet. So we'll create a VNet gateway. Next, we'll go to point to site option in the VNet gateway. We'll upload a certificate. So here we will use self sign certificate. Normally there are different options, like you can buy a certificate from any CA certificate authority. You can use this website Let's Encrypt that provide free certificate. So you can use any public certificate or you can use self certificate. In the organization, they will always use certificate signed by certificate authority CA. So next we'll upload the certificate. Then we'll download a VPN gateway client and then we'll connect it. So if I'll go to virtual network. And we'll create a gateway subnet. So if you'll see, I've already created, or you can create it a gateway subnet. You just need to name it as a gateway. Or if you'll see over here, I will go to subnet. There is option to create a gateway subnet. Since it's already created, if you want, I can delete it and create additional. So it is nothing different. It's just like creating a subnet. So I created a subnet, gateway subnet. Next, virtual network gateway. I will go to virtual network gateway, create a virtual network gateway. These are the options like subscription, name it, region. You can choose VPN or express route. Since we are using point to site, so we'll use VPN. VPN type route based or policy based. SQs, we already discussed all these in last session. SQ type generation, virtual network, public IP address. Since public IP address is required for the site to site, so on the both end there should be public IP for site to site. But when multi-point point to site, we need public IP on the gateway. So we need to create a new public IP. For high availability, active. Just a second. Okay, sorry guys. So we were looking into the virtual network gateway. So in order to create point to site VPN, we create a VPN gateway subnet. Now we are creating a gateway. So over here we have a number of options like public IP, virtual virtual network we want to create this gateway, VPN route based for high availability, active mode. So if one gateway goes down, we can connect to another gateway. If we are configuring a BGP, then we can use configure BGP for the AS number for routing. And this only works in the case if we have virtual router, ISR router on our on premises. So from virtual network gateway, if we want to configure BGP, then we can enable this and we can use routing or we can work on the ISR router for the routing part of BGP. Review and create. So once gateway is created, we'll go over here and from here we'll go to point to site. So point to site, there's option to configure. I will configure. I need to give a address pool. So suppose when you connect from your laptop to your organization through any tool, so any client like any connect pulse secure, it will give you a IP address, private IP address like 10.1.1.1 or 192.168.1.1. So this is the pool that will be automatically assigned to all the users trying to connect to this VPN for Azure connectivity. Dot 192.168.1.0 and one up to suppose 24. Okay, so we need to select the address pool. I'm not sure it should be the in the format of this. Okay, then we need to add a root certificate. So for the root certificate, we have options like either go to public, CA certificate, or we can use self sign. So self sign is normally not used, but over here we need to use a self sign certificate and we need to upload the data. And once this is done, we need to download the VPN client. Once VPN client is downloaded, so as of now it's failing because we need to enter the root certificate data. So we'll refer the documentation. So this is how you can create a self-signed certificate from your laptop. So there is command for the PowerShell, Windows PowerShell. You can use for your organization like @servertech.com. You need to give the name and other details as well, email ID and key encryption. Algorithm used will be the RSA. Encryption will be a 2048 bit and it will create a self-signed certificate. So if I will go on my laptop certificate store, so you can see this is the self-assigned certificate I created, and this is the root certificate that need to be uploaded over here. So detail I need to upload details over here. This is for the machine use so that machine can connect with the Azure. So we need to use this, and once VPN client is downloaded, we can use it to connect over the Azure. So this is the point to site. We'll see its demo in the next class. Next is the other like connection from one virtual network gateway to another virtual network gateway. So VNet to VNet. We can go to selecting the name site to site IPsec. If we are creating IPsec, then we need to create a virtual network gateway and one more additional thing, that is local network gateway for VNet to VNet or site to site IPsec connectivity. Over here we can use the shared key, pre-share key for the encryption. We can use Azure private IP address and the protocol for the encryption IKV or IKV2, and then OK for the side to side. So we need to add this connection on the other end as well. So this same config, we are using another Azure resource. So we need to add a gateway over here using this configuration and on the other VNet gateway. So this VNet gateway is over here. VNet gateway on the your on premises or on another Azure, there should be another VPN gateway. So you need on the VPN gateway, you need to go to gateway tab and configure all these details. Once details are entered on the both end, it will set up a tunnel between one side to another side and data communication will happen privately over the internet. So this was the another thing. So we'll see this point to site VPN gateway tomorrow, and I will give you a test tomorrow. This test will contain all the AZ104 exam questions. And once these questions, I mean, you have attended the test, I will discuss the answers. So am I good?
Yes, sir.
Any questions? Any doubt? Any questions? Okay, looks like there is nothing else. So we'll continue it tomorrow at 3. And first of all, I will post a link tomorrow on the chat section, and you can click on that link and attempt the exam questions. And those are the real questions, they do come in the exam. So either previous year questions or somewhere that might have come in the exam. Okay, guys.
Okay,
See,
Okay,
okay,
sir.
see you tomorrow. Bye bye.
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 Thank you, sir.
Thank you.
sir.